It's time for Security Now. Steve Gibson's here. Yes, as always, the news ripped from the headlines of today's paper, including the Great Firewall of China and now the Great Cannon. How do they work? Steve explains all next.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Security Now is provided by CacheFly at CACHEFLY.com. This is Security Now with Steve Gibson, episode 504, recorded Tuesday, April 21st, 2015. Great Firewalls and Cannons. Security Now is brought to you by NatureBox. NatureBox ships tasty and guilt-free snacks right to your door with over 100 flavors to choose from, like Asiago and cheddar cheese crisps, pistachio power clusters, and Big Island pineapple. You'll never get bored with snacking again. Try NatureBox at naturebox.com/twit. That's naturebox.com/twit. And by ITPro TV. A good IT pro is always learning. And ITPro TV is the resource to keep your IT skills and knowledge up to date. ITPro TV offers engaging courses now with ethical hacker training streamed to your Roku, Chromecast, computer, or mobile device. For a free 7-day trial and 30% off the lifetime of your account, go to itpro.tv/securitynow and use the code SN30. It's time for Security Now, the show that protects you and your loved ones online. This guy is the Great Firewall of Gibson. He protects us all. And you know what I love about this show? You also listen and learn. He's a great teacher. Thank you for being here, Steve Gibson.
Hey, you know me. This is a pleasure. On the 500th episode, I thanked everyone for their being here because they're always thanking me. So, you know, and I know that this is a useful couple hours that we spend every week.
Useful, fun, and enlightening. And by the way, thanks to Mike Elgin for filling in last week. We were down at over at the NAB show. And
he did a great job with the Q&A.
Good.
And it's funny because when I don't have you, I'm always a little self-conscious of that we'll be talking about things that you won't get. So that, because it's, you know, this podcast, probably more than any other one.
You cannot miss an episode.
It builds. Yeah. It really does build on the things we've covered in the past. How many times am I saying, oh, we talked about this 3 weeks ago, we talked about this 4 weeks ago, and this, now this is happening, blah, blah, blah. So I'm always thinking, oh, Leo won't know about this. Well, that's okay, But, you're rare, although I was going to say you're rarely gone, but you are talking about trips coming up. So is that in the summertime sometime?
Yeah, just so you know, I'll be leaving June 27th through July 14th. Lisa and I are going on a river cruise down the Rhine.
Nice.
And the Main and the Danube.
Well, but you need to refresh.
You got to take a break. But I got to say, because you're the same way. It's our passion. I do nothing but read tech news day in, day out, wherever I am. So it's few are the stories that I haven't been reading about and cognizant of.
Right.
What frequently happens, though, and I know I'm not alone in this, is I read a story and I say, I can't wait to hear what Steve has to say about this.
Yeah, I'm seeing people tweeting that a lot, too. They'll say, oh, this looks bad, but we'll have to wait to see what Security Now says. So, because, a lot of this stuff does take some interpretation. We've got a really interesting, sort of a very brief follow-up on TrueCrypt audit that we talked about 2 weeks ago. That was the topic of our show 2 weeks ago. Everyone's talking about a nasty IIS bug that was part of the Patch Tuesday, last Tuesday's Patch Tuesday, which is bad because it is just so easy to do. We'll talk about that. I found an interesting, sort of from a privacy standpoint, new service that Google is offering that I want to talk about. Also, some changes in Chrome, a popular library in iOS that has some people worried. News of Let's Encrypt, which is the automated server is able to issue its own SSL certs service, which is moving forward. And then our big topic for the day, the title of the show is China's Great Firewall and Great Cannon. there's been, in the wake of the cannon blasting that they were doing of GitHub, like mid-March, now we understand much more about the architecture of the system. Well, we've never really addressed the Great Firewall at all. I understand exactly how it works now. And we did talk about the Great Cannon, but I want to tie that all together because this is a major actor on the internet, not only choosing to censor the content that gets into China, but now, as we know, actively using other people's machines for cyber warfare. And it's just, I feel like it's science fiction, but it actually happened a few weeks ago, and it was embarrassingly public. China never took any responsibility for it. They sort of deflected the questions. We now have hard evidence that it was a state-sponsored attack intimately tied to the Great Firewall, which we know is a state-sponsored internet filter. So lots of new information that I think will be interesting to share with our audience this week. Very, very exciting.
Probably you should have some sustenance before you begin today's program. It's time for a NatureBox commercial. So those of you who haven't eaten lunch yet, you may want to avert your eyes because I'll show you some treats, some delicious treats. NatureBox is a snack company that is making better snacks than the kind you probably are getting in the snack machines at the back of the office or stuff you might even have at home. These are snacks designed by nutritionists to be delicious, crave-worthy, and good for you. 100 healthy and crave-worthy options. They come to your door on a monthly basis, which is a lovely thing. They're always made with 0 artificial flavors, 0 artificial colors or sweeteners, 0 grams of trans fats, no high fructose corn syrups, just the best stuff. I'm looking at right now, what are these? The blueberry Greek yogurt pretzels. These, I'm glad we got more of these because Sarah Lane decimated these. I'm not kidding. She loved these. Now, Lisa loves and actually she's not alone, the Big Island pineapple. My mouth is watering. It's hard to do this ad. These are just simply dried pineapple rings. What are the ingredients? Dried pineapple. That's all. And boy, are they, I don't know how they do it, but the best dried fruit ever from NatureBox. Cherry vanilla granola, sriracha Pop-Pops. You'll notice some are sweet, some are savory, some are spicy. Sriracha Pop-Pops, very, very spicy. But all of them are delicious. Well, that's interesting. My doorbell just rang at home. I'll talk about that at some point. I have a new doorbell.
Oh, my goodness.
And they're good and good for you, which I love. Much better than the other snack options. So try the jalapeno white cheddar popcorn or the carrot strawberry fruit juice or the sea salt Pop-Pops. Get smart about snacking. These dried figs I love. But now here's what we're going to do. We're going to send you a trial of their favorite snacks, the top 5 most popular snacks. You just pay $2 for shipping. And it's a great way to get a taste of what you're missing. naturebox.com/twit to get that trial of favorite snacks delivered to your door and a chance to order more. I know a lot of people now who live for their NatureBox. By the way, these are resealable bags, so you don't feel like you have to eat the whole bag. In fact, you probably wouldn't because they're pretty plentiful, servings here. But I just love them. naturebox.com/twit to start your trial, your free trial today. Do it. You're going to love it. Yeah, talk about Internet of Things. What is that?
I love this.
Oh, you're playing Hook.
This is Hook.
Don't play Hook. You're gonna get hooked on Hook. This was my pick for Mac Break Weekly. It's a new game on iOS, and it's hard to stop playing. It's on Android too, by the way, which is nice.
Oh, good. It's just Hook. HOOK.
Yeah.
99 cents on iOS on the iTunes store. And while you were doing the commercial, I did the first 10 levels, and it's like,
now you're just getting started, though. You see,
this is for me.
Yeah.
Oh yes,
Let me just see before we go on who's at my doorbell. Oh, it's the Molly Maids. Oh, okay. So they rang just to see if we were there. All right, good. See the car there. I can take a little picture.
Oh, my goodness.
This is a $200. It's called Skybell. You put it on. I replaced my regular doorbell with the wiring of the doorbell wiring. The doorbell still rings at home. But now when they call, it turns. You can hear the mic. You can hear the noise, and you can hear see the picture. And I can talk to them. I don't want to scare them, but I can talk to them. And I can't open the door. And I got to get the Schlage lock for that. But
that'd be good for Halloween. You could.
kind of. The world is an amazing place. I'm glad it doesn't unlock the door, because after hearing you and the Internet of Things and the issues that could go wrong,
oh boy,
probably better that it doesn't unlock the door. Yeah.
So the picture of the week on the front page of our show notes is a pop-up that I got when I began to experiment with a new feature that Google has made available that we'll be talking about in a minute. But it was big, so I stuck it up there on the front page, and we'll come back to it. I wanted to quickly do a little bit of a follow-up to the TrueCrypt audit coverage from 2 weeks ago, because I spotted something on the net from Tom, he would be upset if I called him the lead cryptographer. He was the team lead or the managerial lead, and Tom Ritter is a cryptographer. He was one of the 3 who were part of the TrueCrypt audit. And I found a quote by Tom saying, quote, "The audits of TrueCrypt get a lot of press because it's something flashy. But the development effort that went into TrueCrypt at the beginning are immense and incredible. And the developers don't get as much credit as they should for producing a disk and volume encryption project for multiple platforms and for maintaining it for a decade or more. There are successor projects, and they are improving it in their own ways. I'm excited to see those projects grow and thrive and last as long as TrueCrypt did. I still use TrueCrypt," says Tom Ritter, who audited it and is a cryptographer.
That's high praise.
That was my point. I still use TrueCrypt, he says, and want to see it supported in the future. And I have looked at, what is it, VeraCrypt and can't think of the other one right off the top of my head. They're making a point of being forward compatible. That is, of being able to take an existing TrueCrypt volume, presumably, and still be able to interpret it. Although, for example, they're improving some ciphers. No doubt they're keeping the older legacy ones around in order to be able to still function with an existing TrueCrypt container. But I just thought it was interesting that Tom Ritter, who would know better, says, I still use TrueCrypt and want to see it supported in the future. So, and for what it's worth, I'm using it because it still solves the problem, and I will be forced away from it when at some point, it turns out that it can't handle GPT partition types or something like that, where some compatibility gotcha occurs just because of TrueCrypt's age.
And that's fairly soon, right? I mean, in some cases, I think.
Yes.
Yeah.
Yes. Yeah. And so I'm glad that it is being moved forward. And as I said, I'm so glad for the audit because it spotted a few areas. They weren't critical, but might as well fix them in the code that is now alive and fixable. And I guess my point was that I'm always going to feel more comfortable with a third-party solution. I just, using BitLocker from Microsoft is like, they're not going to show us everything that it's doing. And it's hard to trust that there isn't some way that they could honor a demand for a drive to be decrypted. And I only, the reason for using it is that it really, really is safe. So the industry
Where can we get it, by the way? I think it's worthy of a note there, because you're preserving because you can't just go to TrueCrypt.org anymore.
No, I grabbed the 7.1a, all of the archives and resources at that time. So it is at grc.com. I think if you just put like TrueCrypt into Google, for a while at least, GRC was one of the links that came up pretty quickly in a Google search. So, and a lot of people are visiting that page and grabbing the content from me. And I think it might have been, I don't remember if it was somebody was also maintaining the hashes on a separate site. So, oh yeah, there it is, GRC TrueCrypt, the final release archive.
Now, if you get it from, if you get 7.2 from the TrueCrypt site, don't.
See, that's the one that they deliberately neutered. This is why we knew it wasn't something done overnight, because 7.2 only removes TrueCrypt. You can't use it to install TrueCrypt, and that's a non-trivial change. They had to go through all of the code and like remove all of the aspects of it that were about creating a new volume. Turns out there was a lot there that they had to do. So 7.2 will interpret a TrueCrypt volume, but it will not create one, and it will allow you to remove it. It'll decrypt a drive for you. So that's the only thing that they're now making available.
Do you? I mean, obviously, Tom, is that his name?
Yeah, Tom Ritter
is not using VeraCrypt. But do you recommend that people go to your site, download the final release of TrueCrypt, or would you recommend they use VeraCrypt?
I guess my sense is, I mean, I'm sure VeraCrypt is fine, but TrueCrypt is bulletproof, and my recommendation would be, if it works, but you know me, I'm sitting in front of XP, Leo, so I'm really I'm a bit of a skewed sample. But my sense is, if it works, use that one. It's been really just pounded to death by, you know, hundreds of thousands of people. That is, the original TrueCrypt 7.1a. If you know, but at some point it won't work for you because your system will no longer be compatible, in which case you'll want to go explore the forks of TrueCrypt. That would be my strategy. I think there's nothing that they have done that makes theirs superior to what TrueCrypt was, because there was just nothing wrong with the way it was.
Yeah. And it has been vetted, and it has been audited, which
Yes.
you can't say for anything else. So there's that too.
And it is so easy to make a mistake. In fact, that is our next story, because this bug was not in Windows Server 2003. It apparently got introduced in Windows 7 and the same code base, which is Windows Server 2008. And 8.8 and 8.1 and Windows Server 2012 and the core installation. Anyway, this is the bug that the security industry has been abuzz about, mainly because it is horribly easy to do. Microsoft gets in trouble always when they move stuff from the user space into the kernel. You know, how many times have we run across JPEGs or, you know, image files that are able to take over your computer? It's crazy to have an image file able to, you know, execute code on your machine. But they famously moved GDI, the graphics device interface, from user space down into the kernel at a time when they were desperate for more performance. And the so-called ring transition, when an application needs to call an operating system service, the application has limited privileges, and it needs to connect to code in the kernel that has infinite privileges. I mean, literally, it can read any address it wants to. It can do anything. The kernel is maximally privileged. It turns out that the architecture to make that transition in a carefully controlled, secure fashion takes some time. There's lots of caches and buffers that need to get flushed and switched, and so every single time the code in the user space has a request for anything from the operating system, there's some overhead. So when you're desperate for performance, as Microsoft has been at various stages during the history of Windows, one of the things you look at is, if instead of having code in the user space, which is making lots of calls into the kernel, it's so tempting to move that code itself into the kernel, because then there's no more transitions. You'd still have to talk to that from the user space, but for example, the user might say, give me draw a rectangle at these coordinates. And so that command goes one transition into the kernel. Then the graphics device interface code is able to just go, and do it much faster. All of the individual, colors and pens and corners and roundings and shapings and mergings, all the complicated variations can be done far faster than if it was living with the application in the application space and had to keep begging the kernel to do all these little things for it. So Microsoft did that when they moved GDI in the kernel. They faced another temptation, which they succumbed to, when they moved a chunk of IIS, the server, into the kernel. And they did it in a module, a kernel driver called http.sys. So it is basically they looked at a way that they could cut the server in two so that with a minimal amount of relocation, that is moving the smallest amount that made sense into the kernel, they could get the most bang for the buck. And so what they did was they created in Windows 7, and which corresponds to Windows Server 2008 and all the subsequent OSs, because this has been there, they allow the kernel to parse the HTTP query enough to see whether the item being requested is in the cache. And they also put the cache in the kernel. So the performance gain is potentially dramatic, because we know that so many websites are fulfilling requests from cached resources. Like all the images that the same images that they're serving, not just over and over to the same browser, but to all the different people whose browser needs to get at least one copy of the image. Well, if it's already been found in the file system and pulled down into memory and it's sitting in the kernel, there's all kinds of optimizations you can do. Windows can just sort of point some pointers at it, and it just shoots that asset back to the requester. Well, it turns out they made a mistake, which is pretty simple, but of course all of these mistakes are simple in retrospect. And on the show notes here, I show the piece of code which is incorrect. Basically, one of the request headers that a browser or an HTTP client can include is called range. If you don't specify a range, then the server assumes you just want the whole thing. But you can also say, for whatever reason, maybe you're actually running 4 connections in parallel, and each connection is getting a different piece of something large, and you're doing that. That's what the download accelerators did for years. For whatever reason, it's in the HTTP spec, and that allows the browser to say, okay, I want this, but start at byte 702 up through 5027. You can just arbitrarily say, this is the first byte of the object I want, this is the last byte. Well, if you have a first and last byte, one of the things you need to do is determine how many bytes that is. The way you do that is you subtract the beginning offset of the range from the ending offset. That gives you the difference. But this is one of the tricks in programming. The difference is not the number. Because say that you said, I want to start with byte 2 and I want to end with byte 3. Well, if you subtract 2 from 3, you get 1, except that the range is inclusive. So you actually need 2. So you subtract the smaller, the beginning from the ending and add 1. And in that code that you've got on the screen now, Leo, from the show notes, that is exactly what they're doing. They have 2 64-bit values. Each of those, and this is 32-bit code, because, for example, the EAX register and the EDI, those are 32-bit registers. But the range, but 32 bits only gives you 4.3 gig, as we know, and things can be bigger than that. They can, and so IIS is treating them as 64-bit sizes. And so that first subtraction is subtracting the low 32 bits of each of the ends of the range. And then that second one, the SBB, that's subtract with borrow. In case there was a borrow from the first, the result of the lower side subtraction, that then subtracts an extra one from the high side subtraction. And so once they're done, then you can see they add 1 to EAX, and then they add with carry 0 to ECX. That's because if the add of 1 to EAX does overflow, EAX goes back around to 0, it'll leave the carry bit set. And so when you add with carry a 0 to EAX, that essentially adds that 1 that fell off the high end to ECX. So what they missed, and you can see it right there, no test to see if that add of ECX overflows. They didn't check for overflow. So it turns out that in practice, simply using a crazy range header, and I showed here in the show notes, anything, pretty much anything, and then as the starting location, and then this special number 1-844-6744073-709-551615. That's the maximum value that a 64-bit quantity can, unsigned quantity can contain. And so this, I'm sure this code was written in C, and so in C they were subtracting a long, which was the starting point of the range, from a long, which is a 64-bit quantity, from the ending point, adding 1, and they didn't check for overflow. And as a consequence, anyone making a request of IIS with that range line will crash the server. It just BSODs. Microsoft called it a remote code execution exploit. Nobody has figured out yet how to actually make that execute code. There are some people who have figured out how to get some information disclosure. Apparently, ranges can also have multiple components. It's crazy. You can say, like, I want from 2 to 5, and then 27 to 46. And so you can create like compound ranges. And it turns out that people who've been playing with this have been able to get the server to send them chunks of memory beyond the object that they are requesting. So that is definitely information leakage, and we don't yet know how bad it is. But it turns out it's much easier to crash the server than it is to get it to give you additional information. Nobody's figured out how to make it execute. Maybe if you had, I can't even imagine how you could do that.
We've talked about this before, the first step is always a crash, which can be used as a denial of service. Second step is to see if you can get it to jump somewhere and execute some arbitrary code. And that takes a while. But the fact that you can get it to crash is always a very, very, very bad sign. It's interesting. So that we were showing assembly language. It was written in C, most likely.
Yep.
It did say,
Yeah.
I noticed the subroutine was at 32.
Yes. Actually, that says UI a pointer to parse range, and then it says at 32. That's a notation for the number of bytes of arguments. So whatever this parse range routine,
the disassembler gave you or something.
Yes.
Yeah.
Yeah. So it's a clue to say, essentially, once you're done, pop 32 bytes off of the stack in order to clean up the stack, because the caller pushes the bytes on the stack, and the routine itself cleans up the stack afterwards. So that doesn't refer to the bitness of it. For example, it wouldn't say 64 if it were 64-bit code. It's how many parameters were required by that subroutine.
It's interesting. Whoever did the disassembly must have had access to a symbol table, because usually you don't get real symbol names, real routine names.
That's true, although the developer tools do have the debugging versions of the code.
There you go.
And so you are able to figure out what all that stuff is.
Yeah.
And the way Windows works with dynamic link libraries, they sometimes need that also. I mean, they link by name, and so the DLLs will have the names of the routines in order for the linker to glue it all together. So there is some of this inefficiency. Netcraft estimates that there are about 70 million publicly exposed IIS servers on the internet. It is, Apache and Nginx have way surpassed IIS. IIS basically sort of losing the war for dominance. Not that it ever had.
You still use IIS, right?
I do, because I'm a Windows programmer, and I know Windows, and I started. If I were starting today, I would never consider using IIS. But I have a huge investment in server-side code, and I've gotten to know it, and I can't quite say I've gotten to love it, because Microsoft keeps doing this to us. It turns out that I would have been vulnerable, except that one of the workarounds is to disable that kernel caching. And I generate so much content dynamically from my server-side code that I never had kernel caching on. And so I was never vulnerable to this, just, happily. Otherwise, I would have immediately patched. So anyway, this is just, this is a perfect example of a problem that Microsoft would not have had they not moved what arguably should really stay up in the user land down into the kernel purely for the sake of performance. They're under pressure to make IIS competitive, and the architecture that they've got necessitates that they do everything that they can. And putting more of your web server in the kernel, horrible as that is a way to achieve that. But the risk is a little tiny mistake like this can really ruin your whole day. And what's happening is people are getting, this is, by the way, when this was released, Microsoft said there are no known attacks. It's been completely reverse engineered, and it is being scanned for actively on the net, and IIS servers are crashing constantly because because they have not been patched, and the default is to cache content in the kernel for the sake of performance.
Although crashing the server usually means just it reboots, it restarts,
Right. Right. And that's why it's called the denial of service, because you're denying user service while it gets itself going again.
Right.
Now, this is interesting. Google is allowing us, anyone who has a relationship with Google, to download their search history back. I'm not sure how far back it goes. In my case, because I was curious about this, you go to history. I guess it's google.com/history, or the link I have is history.google.com/history. And there's a nice little page that shows some stats about you. And if you click on the little gear icon in the upper right, there's a download option. And you can have Google prepare a zip file containing every single Google search you have made in JSON format for, in my case, it goes back to January of 2012. So I'm looking here, and I just stuck it in the show notes here, so quarterly summaries of every search I've made through 2012, 2013, 2014, and up to now in 2015. They caution you that there's a lot of potentially sensitive personal information here. I mean, this is everything I've searched Google for.
I don't think this is new.
Is it? Okay.
So Google, well, and I'm sure some tech blog discovered this and said it's new, but Google's always had a site called Google Takeout where you can download everything.
Okay.
And you've always been able to do that, and you get to choose what you want to have in here. I don't think search history is new. There's lots more than search history, including your location history. Every once in a while, somebody clicks a link. Google's had this for a long time, google.com/dashboard, and suddenly realizes, oh my God, they're keeping track of everything. And Google's always offered Google Takeout. They've always been upfront about this. I don't think this is new unless I'm missing something.
And I don't know. I mean, I can't.
Yeah, some tech blog published it. I saw it all of a sudden all over the place. Google. It's like, yeah.
Anyway, from my
standpoint,
it's good to know. I just thought it was cool that it's sort of a blast through the past when you browse through like what you were searching for 3.5 years ago. It's like, oh yeah, I remember that. Actually, I have some tabs that are that old, but that's another story.
I bet you do. You can't clear this. You don't have to let Google save it. Most of us do because it gives us some value in Google Now and other things, and Google tailors its searches to previous searches. But Google's always been very clear about this. At google.com/dashboard, you can see what they keep track of. And the one that scares people more often is the location history, because if you have a smartphone with Android on it, they've been keeping track of where you are, unless you turned that off for a long time. This is all in here. Even my Orkut postings are still here.
So speaking of Google and Chrome, they are moving forward in their never-ending march to tighten things up. And with Chrome 42, which is out now, they have finally disabled what's called the NP API. They gave plenty of ample warning notice that they were going to do this. The NP API is the Netscape plugin application programming interface that dates back to the 90s. And I think like Navigator 2.0 is where this first happened. Essentially, Netscape realized that their browser would be able to render HTML pages and JPEGs and GIFs, and I don't think there were PNGs back then, but sort of the standard resources. But there would be other content. For example, a PDF is a perfect example. How could a browser render a PDF in its UI? How could it contain it? So what you need is you need to create a standardized so-called API, application programming interface, that other developers can use to talk to the browser guts so that they just have to handle for example, if we extend this PDF notion, they would create a PDF rendering plugin, which you would then add to Netscape. You register it with the browser, and then when you request something with a content type of whatever it is, like application/PDF, Netscape would look to see if it has anything registered to handle that. If there's a plugin that says, oh yeah, I know how to render those, in which case it would hand control to the plugin, and the plugin would then get access to the physical screen real estate in order to render what it wants to. So this it was very widely supported. Even IE briefly added support, although they dropped it a long time ago, back with version 5.5. So IE has not had support for this Netscape plugin API. However, Safari and Firefox still both do and continue to support it. Chrome's, the Chromium people were just, I don't know, that their claim, for what it's worth, is that it was causing stability problems. It's interesting that Java and Silverlight are both hosted under this Netscape plugin API. So if Java is going to continue to be supported in Chrome, it's going to have to probably change. Chrome has its own API that they call Pepper. It's PP API, which is it's sort of essentially the same thing. And for example, that's the API that hosts Chrome's built-in support for Flash. So the Flash that's in Chrome it's sitting in this Pepper container using this PP API. So if Microsoft or Oracle chose to move their Java and Silverlight over, then they could do that. But as of this version of Chrome, 42, it's now disabled by default. So it's not gone. It won't actually be gone until Chrome 45, which is targeted for September of this year. So there's about another 6 months. At the moment, you may find that stuff you're using will not function, but you can turn that back on.
It's in the Chrome //flags.
Yes.
But I'm curious, who uses NP API? I mean, really, does somebody still use this?
Well, Java and Silverlight are both still using
Silverlight,
it.
right.
Yeah.
Right. Java, who cares?
And there are we've been exactly safer without
that. And Netflix has moved away from Silverlight, so I don't know.
Correct. And Netflix was, as you say, the big Silverlight adopter, but they're away from it. Essentially, the effort is to move people towards HTML5 that can now do so much more than HTML4 or 3 were able to do back then, that you really needed natively written add-ons.
Yeah.
There just isn't that much demand for it anymore.
Yeah, it seems this does not seem premature yet.
No, I don't think it is. Chromium had made it very clear they were going to be phasing out the NP API, giving people as much time as they needed to switch over if they still wanted to do a plugin to use Pepper, which is what Flash uses, in order to get the same sort of services from the browser.
And I'm on Netflix right now in my new NP API-less Chrome browser, and it plays just fine. So I'm not too worried about it.
Yeah, I think Netflix is using the WebM stuff, or the
PP9 maybe, and
yeah.
All right, well, that's good.
So for a few months this year, a very popular networking library for iOS apps called AFNetworking developed a problem. It was broken in January of this year with version 2.5.1 and only fixed 3 weeks ago in 2.5.2. The problem is it skips certificate verification checks. Whoopsie. So at this point,
I love it when Steve says, whoopsie.
Whoopsie.
That's the one thing you don't want to hear your doctor say. Whoopsie.
or staring at the x-rays and going,
So the two together would be bad.
Yeah, it's very bad. So there's an outfit called Source DNA that scans iOS, the iOS app store, iTunes, and they have identified at least 1,500 iOS apps in about 2 million installations, which today remain vulnerable. None of these seem like really mainstream apps, although Citrix Open Voice is one. Citrix Open Voice audio conferencing. Alibaba.com's mobile app, and then, things like movies by Flickster with Rotten Tomatoes, something called KY Bank Agent. That seems a little spooky.
Doesn't sound good at all.
No, it
Whoopsie.
doesn't. And the Revo restaurant point of sale app. So these are, sort of off the beaten path apps, but for what it's worth, they may be apps that people have, and they need to get updated. There is a search tool, sourcedna.com, created something they call Searchlight. So it's searchlight.sourcedna.com/lookup is a search tool that allows anyone worried about a specific app to see whether it is vulnerable, maybe, and whether or not it's been fixed. This is not a huge problem because it's not a problem in iOS, and it's not clear how widespread AF networking is. But if you've got, a sort of a smaller custom iOS app that is doing internet communications, the vulnerability is that it is completely open to man-in-the-middle attacks. An HTTPS proxy could just use a bogus certificate. It doesn't have to be, a certificate that it got from China, Nick. It can it can be expired. It can be wrong. And these apps will not detect that. I was a little surprised that iOS won't detect that either, but apparently it's been verified that it slips right past if the app is using this AF networking library. So anyway, just a heads up for anyone who might be affected by that. Doesn't seem, again, like it's a huge deal. And our illustrious crypto auditors have moved on from the TrueCrypt audit to auditing the Let's Encrypt system, which is really good news. To recap, Let's Encrypt, which is over at let'sencrypt.org, that's a forthcoming new certificate authority. They're going to be a certificate authority. I'm sure that until they get into our root stores, which may take a while, they will verify their integrity and get somebody like a Global Sign to sign their certificate, and so they will be an authorized intermediate CA. The point is, this is that system that we talked about a few months ago. The EFF is behind it, and it's got a lot of major league industry sponsors. The point is, let's make encryption so simple that everyone can do it. Make it, first of all, simple to configure and free, so no longer does it cost anything, and automated. So with just 2 commands to a Linux system, you do an apt-get install let's-encrypt, and then you give the command let's encrypt and then your domain name. And with those 2 commands, your server is online with a certificate. So to do that, essentially, we need the back-end management of the CA, so that the server-side stuff for this Let's Encrypt certificate authority, and we need a protocol. The protocol they call ACME, which is short for Automated Certificate Management Environment, and the server-side stuff is named Bounder, which is largely written in the Go language. And these guys, the NCC guys who audited TrueCrypt, have now been commissioned to audit this technology. So they're going to do a full verification of the code that's been written, the back-end server-side stuff, and take a hard look at the protocol. I mean, this is exactly what we would like as a system like this moves forward. And once it's deployed, and they're still targeting for mid-2015, so we're approaching mid-2015, a few months from now, it will mean that anyone who has the Let's Encrypt module in their server, and I'm not sure, like for things like Nginx. I imagine Nginx will be right there. I'm sure we know that Linux will. It would be great if someone does a support for IIS. The idea will be that the server has a protocol with the CA saying, "Hi there, I am Ajax.org, and I need a certificate." And so you can imagine how easily this can work. It's one of those things where you just kind of want to slap your head, because the server claims to be Ajax, the server for Ajax.org to the CA. The CA probably says, "Okay, here's a blob. Go stick this on your root and let me know when it's there." And so over the protocol, the Ajax server receives the blob, puts it in the root so that it's publicly accessible, and then responds back to the CA, "Okay, blob's there," and then the CA goes and tries to fetch it, through the public internet, gets the blob, verifies it, and says, "Okay, you must be the server for Ajax.org because you've just proven that. So here's your certificate." Then the certificate goes back through the protocol, and the server says, "Thank you very much," and binds it to the IP and port, and you now have security for free. And this thing then is an agent running in the background, making sure that the certificate never expires. If, as expiration date approaches, maybe a month or two before, it says, "Hey, me again, let's do this dance again and update me." And, bing, bing, bing. And okay, now we got another however many years this certificate lives for. I mean, it's so easy. It doesn't have to be a long-lived certificate. And if anything happens where you lose control, you're able to use the same system for revocation. So revoke that certificate. Let me have a new one. Sorry about that. And bing, bing, bing. Now the server's got a certificate
Bing,
again. Bing, bing, bing.
Can I ask a question? Because, of course, I want to. And DigiCert gave us a certificate, and we would love to use HTTPS on Twit. And I've been told that we can't or shouldn't because it breaks our caching. So we, as many high-traffic sites do, we cache heavily. We're using Varnish right now. The new system is going to use Redis and Varnish. It's going to be a fairly sophisticated caching system. And I was told that, well, we don't want to do that because then we can't cache it.
So where are the caches located?
In other
are they
places.
Yeah, that's the problem.
Redis is Redis Labs. It's not
right.
It's not twit.tv. So I imagine we're not alone in this regard.
No, and in fact, when a perfect example is we've talked about how ISPs are unhappy about the move to security because they're depending upon caching. For example, like a big ISP like Cox has all of its customers are going to Google. Well, only one copy of Google's front page decoration and resources needs to get pulled by one customer over a non-secure connection in order for the ISP to cache it locally. Then it is so much more efficient for the ISP to serve those same assets to all, like a big ISP like Cox, to all of its customers who are behind that cache. And what that does is it dramatically reduces Cox's bandwidth that it needs, because it's able to serve all of those essentially redundant queries for the same content from its own local store, which costs it nothing because it's its own network. And that way it reduces its costs dramatically. And so you're saying the same thing, Leo. Obviously, the reason you want to cache is you don't want to have to be serving all of this from your own server over a more constricted pipeline.
And, this is the business of Redis. Redis Labs is one of many providers for Redis caching.
Can you move these to a different domain, like to a cache.twit.tv, and have them manage a subdomain of yours? Because I wonder. I mean, they're going to have to solve this problem one way or the other.
Yeah,
because
Cloudflare is a really good example of a company that does this for people all the time.
Right.
Apparently, it's something in the chat room. Julio says a reverse proxy will solve part of the problem, and Cloudflare is developing a solution to encrypt not only client to reverse proxy, but reverse proxy to host. I'm sure this will be solved. I mean, there's a lot of businesses like Cloudflare that's their business. And obviously, Google's forcing us to do HTTPS.
Yep.
It's a little annoying.
It is. Well, and this is, these changes are painful. Yeah.
Is it really making everything better? Well, if you go to HTTPS right now, https://twit.tv, you're going to get an error because twit.tv is not secure. It's not a secure server. Right. We don't have a certificate. And so thank you, Google. You're scaring everybody with this. Go back to safety. Attackers might try to... No, that's not the case, Google.
Yeah.
Right? This is Chrome doing this. It isn't that it's not, we don't use HTTPS. But this is the beginning of a war Google's going to launch on us and other sites who I think you could make an argument don't really need to do HTTPS. Anyway, thank you, Google.
Yeah. Yeah, I think that the demand for security will come from users. For example, there was another blurb that I didn't pick up on just because we had so much to talk about this week, which was that AT&T Broadband, you probably saw this, is saying that they will, for a fee of $29 a month, they will not watch all of their users' transactions.
Well, that's to make up for the loss of revenue, right?
Exactly. The revenue that they get from watching their users' actions and injecting ads and digging into the content. The problem is, what this is saying is that well, okay, first of all, they can only do this on non-HTTPS connections. That is, they can only do this on HTTP. So this puts tremendous pressure on this ecosystem to somehow penetrate privacy, which our HTTPS gives us. And by that, what I mean by that is, just watch. Mark my words. Here we are on the Security Now podcast. At some point, AT&T customers are going to be asked to put a certificate, an AT&T certificate, in their browser.
Right, because then they can appear inside HTTPS.
Yes, yes. And boy, there's going to be fireworks when that happens because, there are a lot of people who are going to say, wait a minute, I don't want my security cracked by AT&T.
Yeah.
So
just
yikes.
like Superfish. It's the same exact thing.
Yes, exactly.
Because if we aren't HTTPS at Twit, now that, no account, you don't create an account. It's a read-only website from your point of view as a user. Does that mean that we are potentially, manipulable, a great canon, or, I mean, what is it? Why is it necessary for a read-only website to be HTTPS?
The only vulnerability I could see is that if someone wanted to inject malicious content onto your pages, they could do that. So Twit content would be going in the clear all over the net, and it's just a page is just a bunch of text. And so somebody could easily change the ads or add content of any sort that they wanted to, if somebody wanted to.
How would they do that?
It's actually pretty trivial.
Do they have to compromise the end user's system?
Well, they do have to be in the middle somehow. Yeah. So I just saw a tool the other day that was demonstrating a man-in-the-middle attack in open Wi-Fi environment where it was just ARP spoofing. I mean, you actually can redirect the traffic of people in a open Wi-Fi environment through your machine and then mess with their traffic. So, I mean, I guess the problem is that the world is going to encryption, but at some point there may be so much pressure put on not having encryption that we start being forced to have certificates in our browsers to allow people to proxy and cache. So, I mean, it's not clear how this is all going to evolve. But boy, I mean, there are a lot of people who will not be happy if their ISP starts saying, sorry, if you're going to use us, and by the way, you don't have a choice, you're going to have to allow us to look into your traffic.
Well, I'm hoping that somebody will solve this for us.
So do you have a different domain for these cacheable things, or is all your traffic running through this other company?
No, it all goes through Twit. So I don't know. I'm not exactly sure what the architecture of it is, and it isn't turned on yet. Right now, if you go to well, it's you've seen people have image servers elsewhere, or people use Amazon Web Server. Or for example, a CDN. Yeah.
But for example, when you have a CDN, it'll often say cdn.twit.tv.
Right.
And that subdomain is somewhere else.
In this case, no. What if you download a Security Now? You're going to go to. It'll be a link to CacheFly.
Right.
And so CacheFly, which is I think is secure. I don't know anyway. But anyways, CacheFly will serve that content to you.
Right.
So when you go to twit.tv, you get text and images in a read-only fashion.
And the media comes from big media services.
Right now, the media all comes from our server. But eventually, nothing will. Well, it still all come from our server, but it will be cached. I guess Redis will be twit.tv. It'll look. I mean, it won't look any different to you. I don't know how it works.
Right.
It's too modern for me.
In order to answer the question, we'd have to really take a look at the architecture. Yeah. And see. But I'm sure the problem can be solved. And frankly, maybe now is the time for you to think about it rather than not doing it secure and then having to change it later. Address it now. Say, hey, look, the world is going to HTTPS.
Yeah, that's easy to say, but if
twice.
it's $100,000 to do it, which it will be, I'm messed up.
I don't think it should cost anything.
No. Everything costs something. If these are developers, I have to get them to create some.
Oh, okay. Work harder.
Nothing's free.
Yeah. Well, you should tell them, hey, wait a minute. This is the way it's supposed to be. Why are you charging me for doing it right?
Yeah.
See how that works.
Screwed. Thank you, Google.
So, a little miscellaneous note that I just caught, and that is that Twitter, as of yesterday, now allows optional DMs from anyone.
I ain't doing it.
I am.
You're going to turn that on?
I did.
Wow.
Well, because I have a lot of dialogue, and the way I'm using Twitter is sort of as a forum, and I am a little self-conscious when there's like sort of off-topic dialogue that's going back and forth, and everybody is like seeing this nonsense. The problem is when I was using it much more as a one-to-one communications, I kept getting complaints from people saying, hey, I can't DM you because you're not following me. And, they were typically following me, so I was able to DM them. And anyway, I think for me, this is great because this allows someone to send something to me privately, that's not for everyone. And typically they will be followers of mine, so I'm then able to respond, and I'm just not junking up my feed with like, random conversation that's not of greater general interest. So anyway, I just wanted to let everyone know that just became available. You go to under security and privacy, there's a privacy section at the bottom of it. It says direct messages, and the little checkbox is receive direct messages from anyone. And mine's on. I can always turn it off if it turns out to be a problem, but I just don't see it being a problem.
For you, it makes perfect sense because you're in the security field. You would want private communications from people you don't know already.
Right.
Of course, they could email you, but you don't use email. I'll just let people email me because I just don't want a whole bunch of DMs from strangers. But yeah, I mean, it makes sense for you though, actually. So it's nice that it's an option, I guess.
I like it, and so the concern is that because I mean a DM as opposed to an @ mention. I mean that's the way everyone's communicating now is they just do @SGGRC and they know it'll and it's public and it'll be in the feed. So people are so what you're saying is you don't want people knowing that they're able to communicate with you privately through Twitter.
Well, that's what email's for.
Right. Okay. Yeah, makes sense.
Yeah. Twitter is such a cesspool for me that I don't. Those are exactly the people I don't want to talk to me.
So a little bit of squirrel news. I had coffee on Friday morning with Stina Evansvard of Yubico, just to sort of catch up. She was down here doing some corporate business, and whenever she comes down, she says, "Hey, Steve, I'm in town. Let's meet at your Starbucks." So we did that, without like getting anyone overly excited because it's premature, I'll just say that Yubico remains very interested in coming up with a solution a Yubico solution that works with Squirrel. They have the technical ability to do that now with the way their technology has evolved. I'm going to fly up and meet with the Yubico techies as soon as the client is nailed down. We've just in the last week we've been going back and forth on our last few issues about like we've removed a bunch of features and have simplified things. Then we went a little too far, so we've come back, but it's feeling really good now. Stina also essentially just wants to solve the problem no matter who wins. And, of course, she's bullish on U2F, the universal two-factor or universal second factor, which is the branch of FIDO that she's been involved in and which, for example, Google is looking at and that we've heard is going to be part of Windows 10 from Microsoft. So anyway, so we just had a nice conversation. One of the things that she reminded me, I was talking to her about how one of the advantages of Squirrel is that it was not federated authentication. That is, it was just between the user and the site they were visiting. And I also reminded her that one of the things that FIDO wasn't and actually could not be was secure single-factor authentication. That is, FIDO cannot identify you. FIDO can only confirm your identity. You have to first tell it who you are so that the server can send you back a packet which you've asked it to hold for you, and then you authenticate yourself against that. So it's more involved, whereas Squirrel, of course, is your identity, and you're able to assert your identity with Squirrel. Anyway, she was saying that not having federated authentication would be a problem because there were instances where you wanted a real world identity. That is, we've talked, Leo, on the podcast about how maybe when there's some sort of an ID card or an identity, you'd go to the post office in order to be matched up with your ID. The idea being that the post office is a government facility. Or maybe it's the DMV, or maybe it's the TSA people who already run the pre-program would do that. I mean, somehow, if we get to a point where there is an electronic identity which does need to be connected to our real world identity, we need a mechanism for that. And as I was driving, I dropped her off at the airport as she was heading back north. And as I was driving home, I realized, oh, yeah, Squirrel can do that. It's not a problem at all. You could be, for example, at an IRS website, which is where you want to prove who you really are, or maybe in some future a voting website. I mean, who knows? Something where your real world identity, you want to be able to assert an actual identity rather than an anonymous one. So it turns out it's very simple for that site to present you with the squirrel code for another site which knows your real world identity, where you have beforehand you've matched it up, and you simply authenticate with that squirrel code, and your real world identity is able to be associated with you and your current web session. So anyway, I hadn't really thought about it. There was a case where we were trying to prevent fraud because there was a way that a man-in-the-middle attack might be able to leverage that, which we have prevention for. But then I realized the flip side is you could use it in a good way to provide that under the user's control, that kind of real-world authentication too. So, one more check mark for Squirrel. I just thought I would mention, I meant to have somewhere. There was a fabulous picture that someone sent me of SpinRite running on their drive with just a scattering of green R's, meaning that it had recovered the data in that location.
Nice,
I mean, it was I just loved even to see it, to think that here was a system that had, major damage just across the surface. And it was just a beautiful scattering of green R's saying, yep, we worked on that sector and recovered it perfectly. Your data is fine. Anyway, I couldn't find that picture, but I have a nice tweet from the 16th of April, so a few days ago, from an Andre Couture, who just sent me a nice note through Twitter. He said, at SGGRC, SpinRite just saved my wife's school computer. Your latest podcast just clarified some of those numbers I saw. And in fact, he was talking about last week with Mike. I showed a screenshot of the smart system, SpinRite's SMART screen, where it was very clear that this drive was in trouble. And I talked about what those things meant a little bit. So Andre was saying, hey, now I understand that better. And by the way, SpinRite just saved my wife's computer at school. So thanks for sharing that, Andre.
Very nice. All right, let's talk great firewalls and canons. In just a little bit, Steve Gibson is ready. He's prepared. I hope you are too. Before we do that, though, I'd like to tell you a little bit about ITPro TV, a great resource for you if you're in IT and you want to polish your skills, or if you want to get into IT. And a lot of times the best way, the only way to get a job, that first job especially, is with certifications. It proves you know the stuff. ITPro TV is a place to learn your stuff. And they do it kind of like we do. Well, except that they are building new studios. They're going to go to 5 studios. Currently, they have 2 studios, and they do 50 hours of programming, so they're lapping us like crazy. If you go to the episode library, you'll see an amazing range of courses for security professionals, ISC Squared, Microsoft, Cisco, CompTIA, that's the A+ cert. It's very useful for people who are getting into IT. Project management, there are Apple and MS Office certs as well. To learn all about it, go to, by the way, there's Don peering in at the camera. They've come here many times. We love them. To learn more, go to itpro.tv/security now. And I'll tell you in a second how you can get a free 7-day trial and 30% off. But I wanted to tell you about something they're doing. Last time Tim and Don were here, they brought Sean-Philip Oriano, who is the guy. He wrote the book on certified ethical hacking. And you may remember he gave a course which is now available online at itpro.tv, all about that. It was such a success, he's going to do it again. And this is free to everyone. When you watch live, you can see the whole thing. Do you remember we interviewed a guy named Mark Goodman? Future Crimes was the name of the book. Yep. He said the world will need 1 million IT security professionals in the next year or two. 1 million jobs. That's really great news. So this would be a good time to get those certs. If you're listening to this show, you've got the smarts, you've got the skills, but you need to get the certs. So Sean Phillips is going to do a class. It's a 3-week class starting April 27th. So what is that? That's not so long. 6 days from now, something like that.
Yeah.
It's the Hacking Forensics Investigator and Cryptography course. So if you want to get a job in forensics, if you want to work in cryptography, this is a great 3-week course, 9 a.m. to 4 p.m. Your brain will be stretched. But if you can get 3 weeks off, you can watch this live for free. So let's fill the need for 1 million cybersecurity professionals for free. And these guys are great. It starts April 27th. You can watch bits and pieces. You'll get a good sense of it. If you want to do the whole thing, though, for free, you can. 9 a.m. to 4 p.m. You will need to create the free ITPro TV account to do this. That's 9 a.m. to 4 p.m. Eastern. I just love this. Find out more. They just released the courses he did last month, the ethical hacker courses. He is the guy in security, wrote the book. He teaches military folks how to do this. There's also, I want to show you the virtual machine sandbox lab, because this is so cool too. If you have an HTML5 compatible browser, you don't need to have Windows Server or anything to set up a Windows Server, configure it, set up clients, and if you make a mistake, no loss. You just reset it. It's a virtual machine, and you get this free. You get this free with your ITPro TV subscription. You also get the Measure Up practice exams with $79, so you don't take the exam until you're darn well ready. Lots of content in every area. A lot of corporate people use this. There's group pricing available. Harvard uses ITPro TV. MIT uses ITPro TV. UCSD, Stanford, and more. These guys are growing like Topsy. Now they're building their second studio. They now have 2, and they're building 3 more. And I just kick myself that we didn't get into this, but they did. So good for them. Even if you're already studying with a book or even enrolled in a certification process or a technical degree program, it's a great asset and very affordable. So let me tell you how much it costs. First, there's a free account you can create right now at itpro.tv/security now. You'll want to use that if you want to watch this hacking forensics course that's starting next week. Subscription's $57 a month. Right there, that's very affordable. There's a reason to subscribe for a year, because you can then download everything and put it on your iPad or your Android device or your computer and watch while you're in the airplane or whatever. I got a deal, though, for you. You're going to get a free 7-day trial and 30% off the lifetime of your account when you use the offer code SN30. So here's what you do. Go to itpro.tv/security now. This is such a great resource. And I know probably for those 3 weeks we're going to lose you completely, but that's okay. itpro.tv/security now. Use the code SN30. That makes it less than $40 a month or $400 for the whole year. This now is a really, really remarkable deal. Great way to learn. itpro.tv/security now. They add about 50 hours of new stuff every week because they are so cool. Tim and Don and the gang, and they love you, Steve. I think really you in some ways were also the inspiration for what they're doing there. All right.
Well, it just makes so much sense. It's a perfect means of delivering that content.
It is. It's so much better than,
Yeah.
I think it depends how you learn, what kind of learner you are. But boy, if you're watching this, you're a visual learner, you're an auditory. I mean, this is it, right?
Yeah.
So let's talk about cannons and firewalls.
So China, of course, wants to control what its citizens are exposed to. There is certainly the so-called Great Firewall has been around long enough that it's just sort of in the ether. People know that there's censorship of the internet when Chinese citizens try to get content from outside. We've never talked about it specifically or how it works. And it turns out that the technology to implement the Great Firewall is pretty well understood. If we flash back to previous podcasts where we've talked about the way the TCP protocol operates, TCP is the connection-oriented protocol. That is where there's some packets go back and forth between the endpoints, agreeing on a bunch of the parameters that they're going to each use in communicating. The so-called SYN, S-Y-N packet, is short for synchronize, is the way for the originating end of the two connecting points to say, I'm going to start numbering my packets from X. And the sequence numbers in TCP are 32 bits, so 4 bytes, so 4.3 billion packets before that sequence number wraps around. And there are reasons for the sender, security reasons, for the sender to want to choose a sequence number which nobody else on the internet can guess, because there have been lots of attacks over the past where you spoof this sort of initial handshake. So the initiator sends a SYN packet to the server that acknowledges the receipt of the SYN and sends its own SYN back. So that's done in a single packet called a SYN-ACK. And then the initiator acknowledges the receipt of the server's SYN, sending back an ACK, an acknowledgement, so that both ends sort of have the numbering scheme that the other one will be using moving forward. And the other thing this does is it verifies that round trips are possible. That is that, the internet is just a whole bunch of routers sort of loosely confederated, glued together, that sort of just function to move packets in the direction of their destination, but without any guarantee. So one of the nice things about this is by having each end acknowledging the receipt of the other one's synchronize or SYN packet, they both verify that a complete round-trip path through the internet exists. So at that point, the ends are able to asynchronously just sort of start sending data to each other. And if in the case of a web browser, it'll be sending requests for content from the server that will be responding. Now, at some point, either end can decide they're done. They can decide that they're finished with their sending. And so they make that statement by sending a so-called FIN, F-I-N, short for finish, saying, okay, I'm finished. And the other side will acknowledge that and often send its own FIN. So then you have a FIN-ACK packet, which is both saying, yeah, I'm done too, and I acknowledge yours. And then finally, the one who first sent the FIN packet and received the FIN-ACK will send its ACK, and that's called a graceful shutdown, where both ends start up, they agree on numbering, they each send whatever data that they want to for as long as they want to, and then they say, okay, I'm all done, I'm finished. And so they sort of tear down, as it's called, they tear down that connection with agreement. But there is another type of solution, or another way that a connection can be taken down, which is known as an abortive shutdown. And that uses a so-called TCP reset packet. If any TCP endpoint that has established a connection, it's done the whole SYN-ACK dance, and they're sending data back and forth, if they receive a reset packet, a TCP reset packet. What that says is the other end is done. Don't know what happened, don't know why, but it's just basically it's just a hang up. Just shut up, no more communications. This connection is reset. Now, the sequence numbers are crucial for sort of each end knowing where the other one is in their conversation. As they're sending data back and forth, each end is acknowledging the receipt of a set of packets, or one or more packets, saying, okay, I've now received up to this number from where we began. And if a reset packet occurs, it has to fit within what makes sense for the other end to have sent. That is, this is a further guarantee against abuse, because otherwise it would be possible for people just to spray the internet with reset packets, causing connections to be reset. It's not quite as easy as that, because the other thing that identifies the endpoints are the IP addresses and the port numbers. So part of what the whole SYN and SYNAC and ACK process establishes is they're called tuples. Because it's sort of a multi-dimensional connection. It's the IP address and the port and the sequence numbering, all of which have to match. So when a reset packet comes in, it has to be from the proper IP, from the proper port number, then that's a 16-bit value. That's one of 64,000 or 65536 ports. And it has to be sent to the proper IP and to the proper port. And the sequence number has to be within a reasonable seeming window. That is, so there's tight criteria on what allows a reset packet to be accepted as a reset. Okay, with that little bit of primer on TCP, all that we've covered in past podcasts, and anybody who's interested can, if you just go to grc.com/SN, there's a search box on the page, and you could put in TCP protocol or TCP reset or something, quickly find those past podcasts where we went through all of this in much more detail. So now we have China that somehow wants to prevent its citizens from seeing content that it objects to, so-called banned content. What China has established inside of the infrastructure of its major bandwidth suppliers, there are four major, country, state scale ISPs operating in China that terminate all of the incoming and outgoing internet bandwidth for the country, scattered around, scattered geographically around. Inside of the infrastructure, the data centers of all of those ISPs that have outside China connections, is some equipment which implements the so-called Great Firewall. Every single packet that flows in is examined for keyword matches for anything that doesn't that is banned. Now, this is not, and it's important to understand this because the canon works differently. This is the firewall. Think of this as a monitor. That is, it's not a man in the middle. It hasn't been involved in the connection at all. It's passively sniffing. So it's just looking at the traffic, looking at the packets that go by, and there is certainly some sophisticated high-speed string matching going on, because there'll be all kinds of keywords or phrases that China has decided, China's government has decided should not be allowed to proceed in, and they want to block it. But mostly they don't want to block things. So this is sniffing the packets that are going by for anything any string match that China feels is banned content. When something like that is found, a packet is found that contains, excuse me, that contains a banned content string, the packet itself has all the information needed to satisfy both ends if they were to receive a reset. That packet has the source IP, the source port, the destination IP, the destination port, and the current sequence numbers for each direction of travel. So some fast-acting hardware that is the Great Firewall, which has been passively sniffing that flow of traffic, sees a match, grabs the headers for that packet, and immediately synthesizes reset packets for each end and sends them out. So what the recipient sees is a packet followed immediately by a reset, which is a legitimate reset for its connection, because everything matches: source IP, destination IP, source port, destination port, and the sequence numbers. And so what the person inside China, or the browser of the person inside China, experiences is a legitimate connection reset that appears to have originated from the source of this material and will absolutely be obeyed. It just aborts that query. And similarly, a reset is sent upstream to the originator of that banned content. And once again, the source and destination IPs are reversed from the packet that went in the China direction. The source and destination ports are reversed because this one is coming in the other direction. So what is the source in one direction is the destination in the other. And similarly, the sequence numbers are swapped. So what the sender of that packet containing banned content receives is an absolutely authentic, perfect-looking TCP reset that appears, I mean, there's no way to tell, it's not legitimate, appears exactly as it should have come from the person it was sending content to. So it resets it. I mean, it summarily drops the connection, just erases all knowledge of it, stops sending anything. The connection is terminated. No additional packets go out. That is the Chinese firewall. So it's not a man in the middle. You could sort of think of it as a man on the side. There's someone monitoring the traffic that normally just letting it pass by, but on a string match for something banned, that one packet containing that content is all the information necessary for that firewall hardware or system, whatever it is, to immediately emit reset packets and terminate that any further flow of that content. And it's effective. Essentially, it means that nobody on the inside can ever get the stuff that they were looking for if the packet contains a match. It just doesn't happen. The connections just get dropped and you're game over. So that's the firewall. Last month, as we discussed at the time, a few podcasts ago, in the middle of March 2015, something unprecedented occurred. And again, as we discussed, two pages, 2 sites within GitHub went under sustained denial of service attack. And this wasn't, like we were talking before, like the denial of service of crashing a server. This was the classic absolute bandwidth overload. And it was difficult to filter because this also wasn't the old school SYN flood, where you just send a bunch of these SYN packets, these synchronizing packets, to a server, causing it to initiate, believing them all, because any one of them could be valid, having the server initiate all of these connections and then try to honor a flood of connection requests. Instead, these were actual queries being generated by real users' browsers all over the world. So there wasn't not like you could block off China, because the attack wasn't coming from China. It was coming from browsers all over the world that were essentially doing China's bidding for this attack. So what was surprising about this, what was unprecedented, was that this was a very public attack. That is, 2 pages on GitHub which were offering software for circumventing Chinese censorship were being attacked. And this wasn't the first time China had demonstrated their unhappiness with GitHub. Earlier, the entire GitHub domain was blacklisted through DNS, so that no GitHub was available inside China. Well, it turns out that lasted only 2 days because of the massive outcry from Chinese developers who were depending upon GitHub as the incredible resource that it is. So after 2 days of just blacklisting GitHub completely, China backed off and made it again public. Clearly, though, they were still not happy with the fact that there were these 2 pages of software designed to help people circumvent the censorship. So the Great Canon was presumably designed sometime in the past. We don't know the history of it. All we know is that we saw, to devastating effect, its first public use in apparently a state-sponsored, virtually a state-sponsored cyber attack is what this was. So China is unable to shut down all of GitHub because China is making such great use of it, but they decided they would just attack 2 pages. Maybe we don't really understand fully the logic. Maybe to run up the bandwidth costs, the bills. Maybe to just demonstrate that they can do this. It was extremely difficult to block because the way this canon worked was to enlist innocent browsers all over the world. So during the attack, people were probing the operation from outside. Security researchers were fascinated to understand exactly what this thing was and what it was doing. What they learned is that the canon is a man-in-the-middle attack. It is intercepting communications. It is standing in as like a proxy for connections and looking at the content which is passing by. It is based on the destination IP of the content, that is where this stuff is going. It can decide to intercept the reply, essentially breaking that query and intercepting the query and generating its own response. So this is in the same location, and we'll talk about how we know that in a second, and appears to be closely related to the Great Firewall software. In this case, though, some observers have noted that it is where this attack was intercepting queries bound for some destination IP, it's very likely that China also has the ability to intercept queries from some specific source IP, meaning that at China's decision, and we don't know that this isn't even going on now because we wouldn't tend to see this in the same way that we saw this massive outbound attack. It might be that China has the ability with the Great Cannon to selectively target source IPs so that if you ask for if you, meaning the targeted IP, asks for any resource that comes from somewhere within China, that this cannon will intercept the response and can replace it with anything they wish, any kind of, for example, malicious content. So the architecture from what's been observed seems to be able to match not only on the destination of a query, but also on its source. So we have the cannon, which is functioning like a proxy, looking at queries and selectively blocking them from proceeding and answering them itself. The people who were probing this during the attack used very careful packet TTL. There's another field in all IP packets called TTL, which is short for time to live. The idea is that because the internet is, as I was saying, just a loose federation of routers, as packets flow from one router to the next, being essentially advanced toward their destination, this little field, it's an 8-bit field, so it can have a value up to 255, and it's known as the time to live. Every router that receives a packet that needs to then be sent on decrements the TTL field, this time to live field, in the packet that it receives. If it goes to 0, if the receiving router receives the TTL set to 1 and decrements it to 0, that packet will not be forwarded to its destination. Instead, the router will send back to the packet's originator, because the packet, remember, contains a source IP. So the router will send an expired message back to the originating IP saying, we don't know what happened, but this packet has expired. It's apparently been bouncing around the internet too long. So this was an inspired piece of design from the very first guys that created this packet switching network. They realized they had to have some way for packets to die. They had to age off of the internet, or there might be a possibility, for example, of having something called routing loops, where router A sends the packet to router B, thinking that it's going towards its destination, and then router B sends it, well, maybe back to A in the worst case, but maybe onward to C, and then C, through some router misconfiguration, and this does happen, C sends it on to A. So now A will send it to B as it did before, and B will send it to C. So this packet is just going to go around in a circle. So we can't have it go forever, or the internet would just collapse. So all packets die, and it's crucial that they have to be able to. So it turns out we can use this, and this is the so-called trace route capability. To trace the route of a packet, you deliberately set the packet's lifetime to 1, and you put it on the internet just like you would if it was going to actually had a chance to get anywhere. Excuse me. And the first router to receive it will decrement that time to live, which it received as 1, will decrement it to 0. I'm afraid I'm going to have to
clear your throat, my friend, and we will put a little twit bug up that says I don't know what.
Little cup of coffee. Anyway, a little sip of coffee. Anyway, so that first router decrements the TTL to 0 and says, oh, this expired, and sends that message back to you. Well, now you know the IP address of the first hop router, as it's called. Then you set the TTL to 2, and otherwise send the same packet again. Now the first router gets it, decrements the 2 to 1, but that's fine. It sends it on. It's on to the next router that gets the 1 and decrements it to 0. Now it expires, but it expired at the second router. So the IP address of the message coming back to you saying this expired tells you the IP address of the second router, and so on. So by using a slowly incrementing TTL, time to live, of the packets that you put onto the internet, and looking at the messages you get back, you can trace the route that the packet is taking over the net. And if you are clever, you can do the same thing, not, for example, just with a ping packet, but you could do that with TCP. All of the packets which are routed by the IP protocol on the internet have a time to live, whether there's an ICMP, a UDP, a TCP, whatever protocol you're using, it will have the TTL. So these guys who were probing this Chinese boundary that was acting so strangely a couple weeks ago verified that the path was the same and the distance was the same. That is the same number of hops as the Great Wall had and the Great Cannon had, meaning that they were at the same router. And this was done from all the different entry points of China, many different ISPs, many different facilities within the same ISP. And in every single instance, sometimes it was 17 hops, but not 18. Sometimes it was 14 hops and not 15. The packets got the same distance and hit this Chinese interception system behind the exact same router. And one other thing was noticed, and that is the packets that the Chinese system generates, the packets that the Great Cannon generates when it's sending back its essentially spoofed reply, and the TCP reset packets that the Great Firewall generate. There's something a little strange about their own TTLs, which is unusual, but they are identically unusual, which leads the people that have analyzed this to conclude, if nothing else, that they are based on a common software foundation, such that the packets they're generating are both unusual in the same unusual way, and turns out to be synchronized. So everything leads us to believe that there is now an offensive cyber attack tool that is available to China that they can deploy at their whim. It looks like it's able to spoof a response from any asset inside China to anyone who asks, or any specific set of individuals who asks. It's also able to spoof that content in a way that can cause browsers which are asking for content to behave as denial of service reflectors, essentially receiving some JavaScript which causes those browsers to then launch an attack targeted at wherever the people aiming this Great Cannon choose to point it. And it's worth noting that all of this only works if there is no security. That is, all of this only works over HTTP. So HTTPS avoids all of this interception. None of this technology works over HTTPS, which again makes me wonder how long we're going to be allowed to have secure connections one way or another. It might be that China just says, nope, we're going to SSL proxy everything in order to crack open this security, and we are not going to allow VPNs to tunnel through. We're just not going to allow any means to get to us that we're not able to filter. And we see the same pressure from a legislative angle here in the U.S. It's unfortunate that privacy, internet privacy, is under attack pretty much from every direction.
It's hopeless. I give up. I'm going home.
It's all technology. Yeah. The technology works. And unfortunately, in some cases, for some people, it works too well. Yeah. Because it is the case that China is blind over TLS connections, over HTTPS connections. They cannot see into them. And so it'll be interesting to see how long they allow that to happen.
It's always been my thought, and I think others have agreed, that the Chinese government understands that anybody with some sophistication is going to get around what they're doing.
Right.
And they are okay with that. They don't mind if the elites can see what they want. They don't try too hard to prohibit that, as they might in other countries. They're more worried about the rank and file. And
the 99%, not the 1%.
Yeah. So it seems like there's always been a little, a little of a laissez-faire point of view from the Chinese government, that people get around this using proxies and VPNs or HTTPS and so forth. Although I got to say they're getting more aggressive, and maybe that's not still the case. It depends.
Well,
who's in power.
Yeah, and I guess one of the things I wanted to convey is that this is not simple technology. I mean, this was in place before someone decided to to attack these two pages.
Interesting.
So this great cannon, I mean, this is cyber warfare technology. This is, a massive flood from innocent users all over the world. So, I mean, as I'm thinking about this, I'm thinking, I could probably do without ever resolving a domain that's in China. I just don't think I ever need to do that. And it's sort of tempting to just say, okay, fine. I'd rather draw consider that a big black hole that none of my assets ever needs to pull a query from.
In this case, GitHub is probably the Alderaan, and for the giant cannon Death Star, right?
Yeah.
Let's give them a demonstration.
It really, I found it fascinating that they tried to block it completely, and their own people said, "Oh my God, we have to have it."
Yeah.
And I'm sure that China saw it, understood that there was it was too useful for their own developers not to have access to this incredible, open source resource.
Wow. Steve, as always, a great education. And we've got Matt and Jeremy in here who say this is the best show on the network. That's why they're here. They say, the heck with those other shows. We are here to hear Steve. We do Security Now every week at this time. Hey, a couple of things I want to tell you about before we go. First of all, we did mention that we are doing the new Screensavers is returning. And
yes.
I hope you will be, as you were on the old Screensavers, a regular. We won't be talking about the click of death.
No.
Something, we're updating it, right?
The canon of death.
The canon of death. And this is all part of our 10th anniversary celebration. Twit celebrated its 10th episode, 10th year this weekend. And we made a special T-shirt. And I want to make sure everybody knows about this at teespring.com/twit. That's where we sell our stuff. But this is always a limited edition, so don't waste too much time getting it. We have it both men's and women's styles. and a variety of sizes.
You mean don't delay getting it because when they're gone, they're gone.
They're gone, baby. It's got a nice front piece of the number 10 with the TWiT logo inside the 0, and then on the back it's got our official 10th anniversary badge. It's a nice T-shirt that will be something very, nice to have 10 years from now, and 20 and 100 years from now. I was there in the first 10 years. Also want to tell people, we're looking for callers for the screensavers, the new screensavers. Because just like the old screensavers, we're going to take calls on the TWiT Netcam network.
Very nice.
They wanted to call it the webcam network when we were doing Tech TV. And I said, well, that's technically incorrect. It isn't a web netcam. It's a netcam. And so that's why it was called the Netcam network.
So you'll have the technology to solicit calls and like an 800 number of people.
No, we'll do Skype. We'll probably do Skype so we can see you.
Oh, cool. Perfect.
If you have a question you want to ask, and sometimes, by the way, we'll call, you can ask a question about, say, the great Canon, and we'll call Steve in on Skype and have him answer it, right? You don't have to always be in studio. Screensavers@twit.tv is the email address. Screensavers at twit.tv, and we'll choose the questions and line you up. The show, you'll need to be available Saturday afternoon, 3 p.m. Pacific. That's when we record, 6 p.m. Eastern.
You think it'd be about a 2-hour show?
1 hour. Well. This used to be a 20-minute show.
That's right. Just a little quick update. We
got the same basic rundown as the original Screensavers, which was 44 minutes. I think we can keep it around an hour. We'll see. So do email screensavers@twit.tv with your Skype handle. By the way, we want audio and video, so you need to have a camera. An email address we can get back to you. A phone number for backup purposes only. We're not going to sell it or use it in any way. Don't worry. Or the email. And then we'd like your name and location, obviously. And, of course, your question.
Again, so it will be a call-in show.
Not entirely. It'll be very much like the Screensavers.
Yeah.
There'll be segments. It's a variety show.
Yep.
Because there's lots of stuff that we would like you doing coffee, that we'd like to do. But we couldn't do,
There's no real place for it.
Yeah. So this is the place. This will be all sorts of stuff, as the Screensavers was.
Nice.
Screensavers@twit.tv. And don't forget, teespring.com/twit. And this show, my friends, I know you will not forget, is always available in 16 kilobit audio from Steve's site, transcriptions to grc.com. You'll also find all the other great stuff he talks about, including SpinRite, the world's best hard drive maintenance and recovery utility. If you have questions for Steve, you could tweet him. He's at SGGRC and apparently now accepting direct messages. But you know what? Don't use the direct message unless there's a reason you don't want anybody else to see it, right? Public messages are better.
Everybody really liked it when I finally understood how Twitter was supposed to work and just lightened up. I was DMing everyone,
right?
And everyone just said, And so this whole
see it. It's public.
Yes. The @SGGRC works really well, and really, it's difficult many times to get into 140 characters what you want to ask.
Right.
The problem is people want me to do SpinRite tech support through Twitter, and then I say, look, I have Greg for that.
Yeah.
He'll respond to your email. That's what I pay him for. I cannot do tech support in 140 characters. So.
But questions about the stuff we talk about here, that's okay. And, of course, you can do it on his website, grc.com/feedback.
That is where I go. Yeah, on Mondays, of every other Monday, I go there, I dump the mailbag, and I rummage through it to find the 10 questions. So that's really the way to get on the show, is grc.com/feedback.
And we have full audio quality and video as well at our website, twit.tv/SN for security now. And you'll find it wherever you find podcasts. Steve and I have been doing this nearly as long as Twit, almost 10 years. So there's lots of episodes, and it's all at twit.tv or in your favorite podcatcher. Or use
this was the second. This was the second podcast. Yours was the first.
Right. Twit was first.
Twit was first.
Tech was first. Then Security Now. Then Amber with Inside the Net, I think. Or no, it was Net at Night at first.
Ah, right.
Then the GizWiz. And I don't remember after that. Windows Weekly came soon, and MacBreak Weekly came soon thereafter.
Right.
And then it got out of control.
And going strong after 10 years.
Yeah, it's going great. I'm really pleased. And it's thanks to people like you, Steve, so I really appreciate it.
And it's thanks to our listeners.
And our great listeners, as always.
Yeah.
See you next week.
Thanks, buddy.
Bye-bye.
Security.